teacher. I will use the screen recording to teach the mechanics of materials. Okay, and the 2.57, the question is cable AB is 9 meters, and determine the XYZ coordinates of point 8, and the questions have the F with the X, Y, Z axis, and it is easy for overs with the Cartesian vectors, just like this, and there has X, Y, Z 3 coordinates, so we need to use 3D Cartesian vectors just like this, and we will know the answer with this 622.5, and we'll know the alpha, beta, and gamma with the X, Y, Z axis for the angle, and it is easy for the cosine law with the cosine, and this is the O force and this is x-axis force, so you can know the x angle is this and y z, so it is easy for it with the question have the AB have the 9 meters, so we have to know 9 plus 9 course the cosine angle. We will know the AX how long and AY AC, so we know the answer. Okay, the next question is 2.61 and 2.62, and the same with the screen recording. And the question 261 have to know as the cable is occurred to ground at A, so we know the AB length with 8 meters, and if X equal 4 meters, Y equal 2 meters, and we will write it, and we know the rectangle with the line is 2 root 5, so and the questions told us the highest point of attachment along the crown, so we know it is simple for the 90-degree triangle. So if we want to know the crown, it is for this line. This is the triangle's low with the 2 root 11, so this is the 2 root 11s, and 2.62. The questions is 8 meters long cable is occurred to the ground at 8. If Z is 5 meters, determine the location as Y of the supports at A. In addition, X equal to Y, and it is easy because it told us that Z is 5 meters. That's 5 meters, and the AB is the same, so we 8 squared minus 5 squared and load it, and the answer is 6.245, and the questions tell us the X equal to Y, so we know the X Y root is equal to 39, and because the xy is equal, the answer is 4.416. Okay. The next question is 3.9 and 3.10, and the same with the screen recording. And the question is express the moment of each force about the block located at A. And easy to talk about the moment of for a scalar, and if the D is vertical with the force, and this is have the moment, yep, and it is the certainly have to vertical with the force, But if your line didn't vertical with the first, you have to use the this one, scalar formula with the r cross f, just like this with the teachers said about in the class, and we'll see with the questions. Okay, if the FB is 200 and the FC is 250 Newton, and we will know the unit has two force with the moment C is FC, because this has need to the first if with this, because why this is have the vertical with the, this is the D, this is the force, because this is the vertical, so we have to use the F multiplied by the D distance. Okay, so the FC, because FC is have the 30 angles, just with the cosine, so we have to rip, and the C with this, and cross this, same thing, plus 200 with the this. So we change for the meters, just like this, so we will know the answer. And the MB with the same FB have the 25 angle with this, so we have to multiply with the cosine 25 angles, and which the distance is, so change for the meters, we know the answer. And the next 3.10, if force B is 200 and FC is 250, determine the resultant moment about the block located at A. Resultant force is this is with the first moment, we will know, oops, not this one. Okay, I can find it. The result moment is the O force plus with each other, because this has two forces, FB and FC, so the moment is plus together, so the MR is moment result is the total with the two moments, so the answer is 347.04. That's the answer. And the next is 3.25 and 3.26. String product is 3.25 is X. Determine the moment produced by the first C about the point O. Express the result as Cartesian vector. And Cartesian vector just like this. Just like teachers said in the class, the vector formula is the place with the vector. So, 3.25 with the row AC, because this is the first phase, this line, and we know the point C is to x axis is to y axis minus 3, and the C point is 0, and we will know the AC, because A is the 0.06, the RAC is like this, so we know with the Cartesian vector, with the FAC is like this, with the O first, with this F for C is 420 Newton, so we have to know the answer with like this. And with the moment, because like the teacher says, the moment with the R cross the X with like this, the vector, so we know the answer is this. So we finish 3.25, and the next is 3.26. Determine the moment produced by the first B and first C about the point O express the result as Cartesian vector. With the same, we know the RAB with this is the 718 Newton, and the RAB, we know the B point is 0.25 and 0. So we will write like this, and the force with the Cartesian vector with the O force. So we know the answer like this. And the moment B with the same with the moment C, we will with the vector formula, and just like this. This is the watt with the 0.06 with the A, and with the force of FAB. Because we have to know about point O with this, so we know the answer like this. And the question have result with the result of moment, same with the up question. So we will to plus each other, moment B and moment C, and we know the answer is like this. With the next question is 3.33 and 3.35, and in the same with the screen recorded, and with the 3.33 is a pipe assembly is subjected to the 180 Newton force. Determine the moment of this force about the point A. The point A is in here, and the point B here, and point C. And we know the R cos A. We'll know the answers, and we just need to know the resultant force. Here, this is R cos A. We need to know the force 18, how to just to separate for the XY, Z axis. Okay, with this picture, maybe just a little bit difficult to know, and I have to draw this picture to be known easily. And for the blue line is in this surface, and the red is in the 3D axis. So we have to know this x-axis is cosine, because this in here, cosine, and this is cosine 30 with the sine 40 with this axis, and the y for the cosine 30 is the red line, and the cosine 40 in the blue line. And the next is the minus 18, because it is in the this down axis for the minus 18, and with the sine 30, because the list 3D line for the blue line didn't have like in this axis, so just have one sine 30 with K. And we know the answer, the FR is like this. So the same with the vector of moment results will just like this. Here is the same with this, and y is the 0.55 with and 0.4 and minus 0.2, because here we know the R group, just the answer like this. We know the R group with the same. Okay. And the next question is 3.35. The pipe assembly is subject to the 80% force. Determine the moment of this force about the point B. What is point B in here? So just the same like this picture, and with a different line, we will know with the same, because this is FR with the same, and the just need to know the axis with the XYZ with the B, so we know the answer. It's a simple answers, right? And the answer is just like this. Okay, the next question is 3.92 then 3.93, and the same with the recording screen. 3.92 is X. Replace the loading by the single result first. Specify where the first X measure from the end is. Those the measure from the end is, we don't need to think about point 8 first. So with this three first, we have to know what is the F first resultant, and with this, what I wrote with the x-axis with the I. So the first is in here, 450. With the x-axis is like this, with this. So it's like 100 cos cosine multiplied by cosine 16 angle, like this with the x-axis, and this is just like with the y-axis. And this axis we have to know this there with the x-axis with this direction with the 700 meter by sine 13 angle. So we know the answer with this plus this with like this. And the y-axis is like this, where is the 115 multiplied by sine 16 plus with the 300 with this b, and in here cosine 600 cosine multiplied by cosine 13, and because this the direction with the minus, so we have to know the answer like this. And with the Cartesian vector with our FR is 1302 newtons, and we have to know the angle with like this on the answers. Okay, and in the 393 we place the loading by the single result first. Satisfy where the first x measured from the end b. So with the in question x the measure from the end b, we have to know to with this, because we have to measure with this is a the don't need to consider with it. Okay, the next question is 3.94. And the same with the screen recorded. Okay. And the question with this is replace the plural force system acting on the plane by the resultant force and specify its locations on xy plane, xz plane. And I think it's a simple questions. Okay, xz plane, just like the picture saw with what we saw. And the fy, what is fy? These three directions with the fy, because it's only in this system just have only three forces, so we have to know the fy with the resultant force is -10. Okay, and just have a lace force this direction, so we don't have the x and z-axis, so this is totally have the zero resultant force with the x-axis and y and z-axis. And with the moment with the x moment x, because the axis is in like this fy, so the moment with the x is with the 3.05 here, 3.05, because the distance 0.5 is the distance with the x-axis, so the moment is the x-axis. It's simple is, and just the same with this 2.2 multiplied by 2.5 and 5 with this multiplied by 1.5, and y is reverse because don't have distance with the y-axis. Okay, and with a 0 for this, we have the distance with the z-axis, so we don't have the y moment, just have the moment x and moment z. And this is simple with the z0 because the distance, just like here, what we here is the clockwise with like this, and this is the counterclockwise. And for these questions, like we will like this. So this is counterclockwise with the minus. Okay, and we have to know the answers. So if the question asks its locations on xy plane, so we have to know x-axis with the z and the z-axis with the x distance. So we have to know the answer. Okay, for the next question is please 3.108, and listening with the screen recording. And the questions ask about replace the distribute loading with an equivalent result force and specify its location on its plane measured from the point O. Okay, with these questions with the area. This area, we have to know the area means the result force. So here we have to know the resultant force. And how to know with the area, I have to separate with the two area just like this. So with the 3 multiplied by 3, and with the triangle area formula just like this, we have to multiply the 0.5, and this is like this. And with the same with this, it has the two triangle with the O area. So we have to know the resultant force is 6.75 kilonewton, and we have to know the location. So with the same, we have to with the just like up to here, we have to know the A have noted by the distance, just like we have to know the moment. So we can know the moment, right? Have to know the moment because we have measured from point O. So with this area, we have the total force. And just like teacher said in class, we have to know the distance here is 3 multiplied by this, and here we have to 1.5 multiplied by this. And here, because we have to with the force in here, so this has the 2 meters. And here we have to know this, just like because we have to know the O measured by O. So here is the distance. So with the this, we have to know the moment, result moment like this. So we have to know the moment force and moment, resultant moment and resultant force. Just we have to know the answer. The distance is 2.5 meters. I'm sorry for the noises with the question, and I just go outside. And the next question with this is 3/109, and the same with the screen recording. And here the question with replace the distributing loading with the equivalent resultant force and specify its location on the plane measured from the pin at A. So I just separate this area with two different. One is like this area, one, and this is like, and this triangle is 2. So replace 2, first 2. Here the distance is the 6 meters. here. And the triangle with clear, because the longest force is 4, so here is a 4 minus 2 here, and the distance is with least is 3, and multiply the 0.5 with least. So the resultant force is 15.5 kilonewton, and the set it acts the location on the beam. So we have to know with the moment and the force, and we can know the distance, because A multiply distance, we know the moment, and we can know the moment, right? Here, with this area, we know the force is in the here, in the 3 meters locations here, and we have to know here's O is moment, and here I have to do 5 with this. Just have to, because I just think the two methods when I studied in the past. And here we know the moment is 51 kilonewton multiplied by the meters, and we can know the distance